We all have a perfectly capable Docker orchestrator on our machines, but nobody's using it. I've been running infrastructure for over 10 years. I still remember one sunny morning asking my mentor back then, what is the best options for containers deployed in the cloud? He looked at me and said something I'll never forget. People tend to develop emotions to technology. They're in love with this, they hate that, but remember, there's no best. There's better, there's worse, sure, but the most important rule in our line of work is using the right tool for the task at hand. So I started exploring. Back then, AWS had an amazing service called Beanstalk, where you deploy your container and AWS takes care of the host. But it had a huge flaw. Just like Docker Compose, if you wanted to scale something, the only way to do that was to duplicate the server with every single container in it. Asking anyone for alternatives would usually end up by going directly to Kubernetes. To this day, this is still the case, which leads people to a simple yet biased decision. It's either Compose or monstrous Kubernetes. But what if I told you there's a better way? One that's not only incredibly easy to use, it lets you scale, load balance applications, self-heal, manage secrets, collect logs, and so much more. It's great for local use, home labs, but also production systems, especially ones that require a few simple nodes and a straightforward deployment. But the best thing, it's fully compatible with your existing Compose files if you have them. So today we're talking about Docker Swarm, the underdog that unfortunately everyone seems to ignore. There are many ways to start a bunch of machines. I'm going with my current favorite, Lima VM, to self-host them on my machine. I made a video about Lima that you can check up here. To set up a cluster, I'll first need a cluster manager, which functions as a worker too, but we need a leader for the group. To apply interconnectivity, I'm going to add the Lima user network so that the VMs can speak to one another directly. Depending on your host platform, you'd want to make sure that's possible before starting out. While that's running, I'll go ahead and use the same template of a Docker host for my worker, which will also run on the same network. We'll also create a second worker to make sure that we see real scale in action. It's time to start the VMs and connect them to one another. Swarm makes things incredibly easy by allowing its CLI to do most of the work. The one parameter we'll need throughout the process of constructing a cluster is the IP address of the leader. That's it. Before hooking things up, it's always worth confirming that the network is set up correctly and that the workers can resolve the manager node. Here, within Lima, I can address the host with an internally resolvable DNS address with its name .internal, which comes up with the correct IP. Let's use that address and hook things up. A Swarm cluster starts simply with Docker Swarm init, advertise address, and the IP. This command returns the initiation of a manager node and a command to join workers, which we're going to use. Let's get a shell on our first worker, paste the command with the token, and just like that, the worker is now a node joined to the cluster. Magic. I'm not sure if you had the dubious pleasure of running kubeadm in the past for setting up Kubernetes from scratch, but this experience is so smooth I'm actually having fun seeing it work without any hassle. I know I tend to get excited about the nerdiest possible things, but this is just sweet. So, Docker info on the manager node shows an active swarm with IDs of the cluster, the node, whether this is a manager, and how many nodes are available. By default, Swarm managers functions as workers too, which is why we're seeing one manager and two workers after hooking only one node. Docker node ls shows our node state and other useful informations like engine versions, etc. So it's time for worker number 2, getting a shell, pasting the command, and that's it. Our cluster just scaled up. There we have it, one manager, 3 nodes, again, since the manager is one of them. Docker node ls comes up with the cluster and it's time to start using it for real. To do that, we're going to create a Docker service, not to be confused with a Kubernetes service. If you've ever used AWS ECS, this is kind of the same. Before we dive in further, let me tell you about today's sponsor, Twingate, the smart way to secure your remote access. You know how traditional VPNs are like having a single fortress gate? Once someone's in, they can wander anywhere. Well, Twingate flips this model on its head with zero trust security. Think of it as a modern city where every street requires its own access path, and a guard asks for your ID before you move on. Much safer, right? But here's what's really cool. Twingate integrates with everything. Your clusters, your backend systems, even your Git platform. Just add it to your Compose setup and see how it works. Everything is protected by zero authentication and you can find yourself in with one finger tap. No context switching needed, setup takes minutes, not days, and work across all of your devices. Plus, you get enterprise-grade security without the enterprise-grade headache. Whether you're managing a remote team or running a complex Swarm deployment, Twingate handles the security, heavy lifting, and you can focus on what really matters, building great software. Ready to level up your remote access security? Head over to twingate.com for a free trial and see why thousands of teams trust Twingate with their secure access needs. In the context of Docker, a Swarm service refers to a containerized application deployed and managed as a service within a Docker Swarm cluster. Just by doing that, we're enabling automated scaling, load balancing, and fault tolerance. The simplest way to go about creating a service is to run docker service create with a number of replicas and an optional name and a container to run. In this instance, we'll follow it up with a command to run, so we're going to ping docker.com just to see the output. Starting another shell on the manager node and running service ls shows an ID in the Alpine image starting. Swarm also waits a while to make sure things are stable before confirming that to the CLI, which feels like Kubernetes for children, but in a good way. No messing about, no templates and setups to fight with or health probes, just pure work. Everything I mentioned is absolutely necessary. Don't get me wrong, but for simple use cases, home labs, even production environments with 2 applications, especially when the cloud is not an option or too expensive as it mostly gets, I'm going with Swarm all the way. It really doesn't get any simpler than this. There are some limitations, sure, and we'll get to them later, but this is the simplest orchestration setup I've ever seen. The service now has 1 replicas up, so we're basically up and running. Let's fetch the logs showing a valid ping to docker.com in half a second, no less. To read the configuration, kind of like kubectl described for those of you who know it, service inspect with a pretty flag outputs a human readable service state including everything you need to know. You may notice parallelism here, which is set to 1 by default, but can also be increased, telling Docker exactly how many replicas are handled at a time. Let's see this in action. We're going to scale our Hello World app by running docker service scale, changing Hello World to 3. Swarm kicks in and the manager starts orchestrating the request, scheduling tasks 1 by 1 given our parallelism setting. Once another is changed to running, the third is handled until we see that the service converged. I think it's interesting to pause on this word selection here. Converge suggests 2 points meet, which in the orchestration world, it's the desired state and the observed state. This is a well-known concept that also Kubernetes shares. When you start a service or deploy a resource, the system looks at this as a request and different processes start working in iterations to bring that request to life with all the configurations. This is slightly different than just installing something. It's an ongoing dynamic process that reacts to a system that changes all the time and actually expects failures in the process. Sometimes it's referred to as a reconciliation loop, another term set to emphasize the 2 parts that need to come together. Docker Service PS now shows a bunch of entries, way more than our 3 instances because it failed a bunch of times over a missing image. If you look closely, the name column actually marks the failed phantom tasks with a backslash, so in total, we only have real 3 running tasks. You'll also note, and that's the whole point of having a swarm in the first place, that the tasks are spread out across the cluster. One scheduled on the manager, another one on worker 1, and a third one on worker 2, effectively creating redundancy and high availability across many nodes. What about load balancing? You may rightfully ask. Well, Swarm comes with the notion of an internal mesh, which is a fancy way of saying it load balances requests to a published port around the Swarm. The routing mesh enables each node in the Swarm to accept connections on published ports for any service running on it, regardless of whether the task is actually running on that specific node. When it's time to delete things, Docker Service RM takes care of removal and garbage collection until things are gone. Our simple service is gone, now let's actually create one that can handle rolling updates. We'll roll out a new service, 3 replicas running Valky, the open source Redis fork. There's a video covering that up here if you're curious. We're also setting an update delay of 10 seconds, which gives us room to breathe and gracefully roll out updates when they're needed. In this way, the Swarm manager hangs 10 seconds between tasks updates of a service instead of the default 0, which can be too quick to some applications. Note that I'm using Valky 8.1, which isn't the latest, and that's on purpose so that we can upgrade it with a new release. The progress slowly changes, and while it's finishing up, we can call again the service inspect command that reveals the status and even the update config we've set with the delay failure ratio, etc. When we want to release a new version, and given the context of your swarm, this might be done by an automated CI/CD process, we use docker service update image and change that to the latest tag. Slowly but surely, Swarm goes task by task since we've set parallelism to 1 and 10 seconds delay, until it completes the rollout and even counts down to make sure everything's nice and stable. The image is updated with the latest tag and its unique hash that we can reference later. If you want to learn further about the change, the service inspect also provides a rollout summary under update status, telling us where we're at and also how long it took overall. So everything we've just shown is when things go right, but sometimes things go wrong. A server is about to crash or needs an update or replacement or many other factors we all know. So, like other orchestrators, Swarm can drain a node, moving tasks away gracefully to other nodes in the system by changing its availability setting. Node.ls shows the availability status, which isn't active at the moment and can be thrown back into the cluster by changing it back to active again. Remember the network mesh from earlier allowing for load balancing? Well, if you need to make changes or update published ports, there's an option for both in the service update command. So I can add a published 6379 to our Valkey service, which can be reachable from anywhere in our swarm. But if you see here a port problem, you're absolutely right. These can conflict with each other using the same port for multiple replicas if they're on the same node, for which Swarm comes up with a publish mode ingress. Using this setting gives you the best of both worlds. Your services are accessible on the standard port, in this case 6379, from outside the Swarm, while internally Docker manages the routing and load balancing. Armed with Docker Swarm, I hope you'd make the right call next time you're thinking about a small-scale system or your home lab. But none of these work well without having a solid Docker container basics. Watch Docker for the Impatient next and tick all the boxes on your way to a scalable production deployment. Thank you for watching, and I'll see you on the next one.